Okay, one of the tougher trig skills is called graph sinusoidal functions phase shift. And there's really two types of problems. One where you have to go from the equation to the graph, and so that's what this video is going to be about. I have another video that shows you how to take a graph to an equation. So it's really just two different directions of the same problem. But if you're going from equation to graph, the first thing I recommend you doing is rewrite the equation, two, write down the transformations, and draw your box. I'll explain what that means in a second. And then check your graph on Desmos before you hit answer. And I'll show you Desmos. Okay. So here's the equation I was given to graph, right? This is the given equation in the problem. And all I want to do is rewrite the equation. And I slightly mistook this. It's not factor out the GCF. It's just factor out whatever the coefficient of x is. So I'm pulling out pi over 5, right? And that only leaves an x. And then which would just be 2 after I pull that out front. Okay. This is so we make sure to get the input transformations right. Okay. And then we just write down the transformations. Each of the numbers in the problem does a little something to the basic graph of sine. Okay, so this 3 right here is going to be a vertical stretch by a factor of 3. That's going to make the waves higher. This really is a horizontal stretch. It's actually a compression here because whenever this value is less than, it's a stretch. Did I say compression? Whenever this value is less than 1, it makes it bigger. It stretches it out. When it's greater than 1, it compresses it. This is going to shift it kind of counterintuitively to the left twice. Okay, you see +2 and you think it's going to shift it to the right twice, but it actually shifts it to the left twice. And then this, all it's going to do is pull the whole graph down 3 places vertically speaking. It's just going to drop it 3. Okay. And then here we go to step 3, draw your box. So this is just a basic sine function, okay? And I'm really just drawing a single period of it because that's all we need really to graph it, is to know a single period. The sine function or the cosine function just repeats itself over and over again. So the basic sine function just goes, and I have a sine in this equation, so that's why I'm using the basic sine function instead of the basic cosine function. So the basic sine function just has a mid line at 0. It goes from 1 to -1 in terms of its amplitude, and its period is 2 pi. Okay, and the middle of its pi, the first peak is at pi over 2, which is like a half pi, right? That makes sense. It's halfway between pi and 0, and then 1.5 pi is halfway between the midpoint and the end point of the period. So that's just where the dip is. Now, the first thing I do is I'm going to vertical shift it down by 3. That's because of that -3 on the end, right? Because of this -3. And so all it does is it changes these y values here. Okay, this what was 1 now becomes -2. What was 0 becomes -3, and what was -1 now becomes -4. Okay, but nothing else has changed. Now I'm going to do the vertical stretch. So now my amplitude is 3 because of this 3 out front here, right? And so now the midpoint's going to stay the same, but now the amplitude is 3. So 3 above, instead of 1, we go 3 up to 0, and then 3 down to -6. Now notice all these, the x values have all stayed the same. This has only affected the vertical look. And I know I haven't written the waves any higher because I'm not really on a scale here like I would be on a normal graph. I'm just manipulating the numbers so that it's easy to then graph. And then we do a horizontal stretch, okay? And I divide by pi over 5, which is the same as multiplying by 5 pi. So I get 0 becomes 0 when I multiply by 5 over pi. This becomes 5 over 2. This becomes 5. This becomes 15 over 2. And that becomes 10. Okay, I'm going to have to do another video for this.